So let's take a look at evaluating some algebraic expressions whenever we're given a certain value for our variable, or for, in some cases, multiple variables. This is kind of a staple thing that we'll do a lot in the algebra class. It's kind of one of the basic things that helps us with our problem solving. So the idea here is we have some expression 2 times x cubed minus 3x, and I want to evaluate this expression for a certain value of x. The reason we call x, of course, a variable is because we can make it whatever number we'd like to, but in this case I'm going to make x be a specific number. And doing this evaluations is relatively simple. All we have to do is go through, and every time we see an x in the problem, I'm going to replace it with a 2. So 2x cubed minus 3x evaluated at x equals 2, we're just going to go through and place that x with the 2 everywhere we see it, and then everything else stays the same. So this becomes 2 times 2 cubed minus 3 times 2. 2 times 2 cubed, that will be 2 times 8. 3 times 2 is 6. Again, I can do multiple rules at the same time when I'm doing these simplifications because there's no exponents here, so it won't affect this value. Lastly, I get 2 times 8, which is 16, and we have 16 minus 6, which ends up being 10. So this expression evaluated at x equals 2 is equal to 10. Now I can do this with multiple variables. I don't have to just have one variable in my expression. So something like this, x plus y divided by 2y squared, evaluated when x equals 5 and y equals negative 3. Again, I'm going to do this the exact same way. Everywhere in my expression that I see an x, I'm just going to replace it with a 5. And then I go back through the expression, everywhere I see a y, I'll just replace it with a negative 3, and then do the simplification, and whatever number I get is my answer. So we only have one x here, so I'll put a 5 there for that x. This is y, so plus y will be plus negative 3. And then 2 times y squared, so that will be 2 times negative 3 squared. Again, just replacing them exactly as you would imagine. So now I just need to simplify my expression. So 5 plus a negative 3, that's the same thing as 5 minus 3. So this will become 2. Negative 3 squared, now be careful, this is negative 3 times negative 3, so that becomes a positive 9 because it's negative times a negative. So this will become 2 times 9 in the denominator. So I'll end up with 2 over 18, or just 1 over 9 for my answer. We'll try one more. So the absolute value of 4x cubed plus 8y minus 3 evaluated when x equals negative 3 and y equals 1/2. Again, I'll just go through, and every time I see an x, I'll replace that with a negative 3. And then every time I see a y, I'll replace that with a 1/2. There's nothing here, so this just remains negative 3. Don't forget your absolute value signs. If you do, then you could possibly get the answer wrong at the end. You might get a negative version of something that should be positive. So negative 3 cubed, this is a negative times a negative times a negative. If you think about cubing a negative, it will always be negative because this number times this number will be a positive, and then the positive times the negative will make it a negative. Or if you want to think about a negative number raised to an odd power will always be a negative number. A negative number raised to an even power will always be a positive number. If you raise a positive number to any power, it's always positive. So the only ones you have to worry about are the negatives. But a negative to an odd power is negative. A negative to an even power, like 2, 4, 6, or 8, will always be positive. So in this case, 3 cubed is 27, but it's negative, and it's to an odd power, so it'll be negative 27. 8 times 1/2 is 4. And sure enough, you probably recognize this from one of the other problems in the book, or one of the other problems in the notes that we've done before. This is negative 108. 4 minus 3 is 1, and so we get negative 108 plus 1. So absolute value of negative 107. So this will be positive 107 will be our answer. The nice thing about these is no matter how complicated I make this expression, if you can just plug in the numbers and do the arithmetic, then you're set and you can do all these types of problems.